Welcome back. Continuing on our lecture slide 1 2. Another important use of a random number table is in simulation. We use the word simulation to refer to the process of providing numerical imitations of real phenomena. All right. So, what is simulation? It is just some way of understanding real phenomena using simple numbers. Okay. Let's see a few examples. Simulation methods have been productive in studying a diverse area of subjects, such as nuclear reactors. Now, nuclear reactors, you are not really going to do something dangerous as an experiment. You're going to use computer system to understand quantitatively what can happen in an experiment. Likewise, cloud formation or cardiology, medical science in general, highway design, production control, shipbuilding, airplane design. Okay, airplane design, that's another important example. You're not going to keep crashing expensive airplanes to understand its safety, but you are going to use computer simulation, war games, economics, electronics. So, to understand any of these, it's very dangerous or not possible really to use concrete experiments. So, you would use what is called computer simulation, right? Now, in a simulation, a complete list would probably include something from every aspect of modern life. A simulation is a numerical facsimile or representation of a real world phenomenon. Okay, so it is a numerical representation. All right. Other sampling techniques, although we will assume throughout this text that simple random samples are used, other methods of sampling are also widely used. So, this is an important point. Throughout this textbook, we are going to assume we are using simple random samples. Regardless, appropriate statistical techniques exist for these sampling methods, but they are beyond the scope of this text. One of these sampling methods is called stratified sampling. Groups or classes inside a population that share a common characteristic are called strata. Strata is plural of stratum. Okay, so like we say, our society is stratified. What does that mean? They mean there are different classes. So there is the based on income level and so on and so forth. So stratification is demarcation. So each layer is called a stratum. All the stratum together, all of them, the plural is called strata. Okay. For example, in the population of all undergraduate students, college students, some strata might be freshmen, sophomores, juniors, seniors. So these are different strata, right? Other strata might be men or women. Okay, that's another strata. In state students, out of state students, and so on. In the method of stratified sampling, population is divided into at least two distinct strata. First, divide the population into at least two distinct strata. Then, a simple random sample of a certain size is drawn from each stratum, and the information obtained is carefully adjusted or weighted in all resulting calculation. So, this is the stratified sampling. So, first divide the population that you wish to study into different strata, at least two strata, and then use simple random sample of a certain size from each stratum. So it's not okay to just select 5 women and 2 men. No, that's not equal, right? The same size. So if you choose 5 women, then you have to choose 5 men randomly. All right. So that would be stratified sampling. The groups or strata are often sampled in proportion to their actual percentages of occurrence in the overall population. However, other more sophisticated ways to determine the optimal sample. Now, here is something, a certain size. Now, if you're looking at men and women, then you are expecting around 50% each. But suppose you are looking at different ethnicities, then you try to get sample based to their actual percentage of occurrence in the overall population. All right. Now, there are more sophisticated ways to determine the optimal sample size in each stratum. In general, statistical analysis and tests based on data obtained from stratified samples are somewhat different from techniques discussed in an introductory course. Such methods for stratified sampling will not be discussed in this text. Okay. In general, deep studies, they use other kinds of stratified sampling which are not to be discussed in this text. Another popular method of sampling is called the systematic sampling. In this method, it's assumed that the elements of the population are arranged in some natural sequential order. Then we select a random starting point and select every kth element for our sample. For example, people lining up to buy rock concert tickets are in order. So you have, say, only 10 tickets and you have 120 people lined up. So you are going to be able to give to only 10 people. So what would you do? Make them all line up in a line and start randomly which number you like, say, right? Say between 1 to 12. Some number you choose. Say, I don't know. Randomly choose a number 7 and then add 12, 7, 8, 19, plus 7, 26, so on until you're out of your tickets. So you randomly begin with the starting point, but then you go in order. Okay, kth element, 10th element, 20th element, whichever. Okay. Next, to generate a systematic sample of these people and ask questions regarding topics such as age, smoking habits, income level, etc., we could include every fifth person in a line. The starting person is selected at random first from the first 5. So say you chose 3 as your first guy from the first 5, then 3 plus 8, 3 plus 5 is 8, 8 plus 5 is 13, and so on. The advantage of a systematic sample is that it is easy to get. However, there are dangers in using systematic sampling. When the population is repetitive or cyclic in nature, systematic sampling should not be used. For example, consider a fabric mill that produces dress material. Suppose the loom that produces the material makes a mistake every 17th yard, but we check only this every 16th yard, right? With an automatic electronic scanner. So we are checking every 16th yard. So we miss the 17th. All right. In this case, a random starting point may or may not result in a detection of the fabric flaws before a large amount of fabric is produced. Cluster sampling. Let's come to this in our next video. Until then.